Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're going to be doing another video of our Tidally Lock series. So last episode we did Venus, and I believe you guys really enjoyed that one along with the Earth one before it. So it seems you guys keep enjoying these, so I'll keep doing them. Maybe we could get around to doing all the planets at some point. But today, like I mentioned in last video, we're going to be heading to Neptune today, as we're going to be seeing if Tidally locking it could warm it up a little or anything like that. Obviously it doesn't receive much light from the sun anyway, it's a lot darker out here, and obviously it's a lot further out than the sun's disk as well, the habitable disk, the zone there. So that's obviously very far away. But we're going to see with what little energy Neptune gets from the sun, we're going to see if tidally locking it makes any differences, because I still am very surprised by how crazy Venus got last episode. But I'm wondering here, would Neptune be able to get into the minus 100s maybe? Could it get to 0? Could it go above? Like, I have no idea. So we're going to be definitely finding the answer to that question today in Universe Sandbox 2. So we're going to be adding our temperature gauge up there like that. I did not want to do that. Obviously Neptune doesn't even have all of these options since it's a gas giant, so we're just going to go ahead and remove those. I was not going to click that, so yeah, there we go there. So I'll leave those two up, why not? So yeah, there we go. Let's go ahead and close that. Actually, no, let's keep it open, actually. Alright, and let's just get straight into this. So, obviously, we're going to head to the motion options, and we're going to tidy lock. So, we're just going to slow down time, click this. There we go. So now the same face of Neptune will always be facing the sun throughout the Neptunian year now. So there we are. Let's disable the orbit mode, make it look a little cleaner around here. Turn off labels as well. And now we just have to watch the temperature of Neptune. So let's see how this works. We're mainly going to be looking at this board here. So, right, let's go ahead and start to speed this up. It's probably going to take quite a while for a change to happen here. Now, I reckon it will probably, maybe the daytime side will go into the minus 100s, maybe, but I reckon the nighttime side is going to be ridiculously cold. So, right, as we can see, we can already start to see, we're covering a couple of months here, we can already start to see some changes in the white area, which is the hottest area there. So let's go ahead and, yes, let's go a lot quicker. So obviously Neptune, it's going to take quite a while for anything to change. We'll be travelling at a decent speed here. Obviously, the inner planets are going crazy. Even Saturn, Uranus, they're going pretty fast. So yeah, there we go here. So let's see what sort of temperatures we're up to now. Okay, so the coldest area is now going into minus 226. In the light blue area, if we go up a bit, minus 230 degrees, minus 231 in the black area. The white area is at minus 216, so it may actually go into the minus 100s, but we'll have to keep looking. So yeah, there we go there. Let's buff the speed up a little more here, so we're really going fast now. We're doing multiple orbits with Neptune now. So there we go. Obviously the same face is always facing the sun, so as we can see, the nighttime zone is getting a lot colder now, so that's going to keep going all the way to minus 270 probably. The hot zone is at minus 208 degrees now. So let's keep this rolling and let's just keep going. So we're traveling at 200 years a second here. We can see absolutely massive amounts of orbits going around the sun now. Obviously, if we just lock onto the sun itself, we can see here, this is just insane. What's going on over here? Is that a glitch? What is that? What's all that trail there? Did something get shot out? I'm guessing that's Mercury. Just because we're running the simulation so fast, Mercury hasn't even been able to hold on. So the inner planets are practically broken by running it this fast. But as we can see, the outer planets are fine. The inner planets have gone nuts. But you can see the outer planets are just going super, super fast. We can see Far Out, Sedna, Planet 9, they're all moving pretty quickly. But anyways, back to Neptune now. So yeah, we're traveling just ridiculously fast around the sun now. But as we can see, it seems to have put my prediction out there that it looks like, yes, so Neptune's ultra cold now in the dark area, but in the daytime it's still at minus 207 degrees. So you can see that tidally locking Neptune doesn't make too much difference to it, because obviously it's so far away anyway that the sun isn't really giving it any extra boost, because it's so far away that there's hardly any boost to give it, because it's already just so cold and dark out here. Not much energy's obviously being received from the sun in the first place. So even though tidally locking it has obviously warmed it up a little bit to minus 207 degrees, it's still not enough to get it anywhere close to 0 degrees and then into the positive numbers. So as we can see here, obviously not as interesting as the other planets, but yeah, it's still one of the planets and it has to be done. So I guess we can throw Uranus and Neptune into the same video here, because I'm assuming we'll get similar results with Uranus. So we're going to go ahead and do that now. So if I go ahead and click this was this one here. So we want to go to temperature. So where are we? Surface. No, not surface data. No, we want temperature. Can we not click it on Uranus? Is Uranus completely broken? Maybe it's because it's a custom. I'm guessing that's why. So we'll throw in the regular Uranus then. So where are we here? Come on, you're going to add it in? Yeah, it looks like the temperature gauge on Uranus doesn't work due to it being a custom object. So that's quite annoying. So yeah, let's just open this menu up. We'll just throw the regular Uranus in here as well. So we're just going to place that in the same orbit. So there we go. Right, and then with Uranus, we're going to click on it. So there we go. So it's just the custom one. It's broken. So then we're going to tidally lock Uranus. We're going to see if Uranus can get any different results compared to Neptune. So there we go. So let's see how this works. So tidally locked here. So we've got Uranus versus Neptune up at the top here. So let's just let this run out for a little bit. So both Uranuses are going around, but obviously one's tidally locked, one isn't. So here we go. So Uranus, obviously we're going to see similar results with the temperature, but it looks like, obviously since it's closer to the sun, it's receiving a little more energy. It is going to minus 189 at Uranus compared to the minus 207 at Neptune. So we can see there, with that difference in orbits between the sun, obviously Uranus and Neptune is about 1 billion kilometers difference there, around that, 1 billion miles, kilometers. Obviously, that billion has made a slight difference from minus 188 to minus 207 there at Neptune. So, yeah, very similar results between Uranus and Neptune. Obviously, they're so far out, they barely receive any barely receive any energy from the sun anyway. So, yeah, there we go there. Obviously, being completely tidally locked. It's going a little weird with all this, but yeah, I don't know why it's doing that. It's a little funny. It's all obviously tidally locked. And then we're clicking on the. We're clicking on the wrong Uranus now? No, we don't want that. We want the correct one. There we go. So this one over here. So here it is. So I don't know why this is going like that. Obviously, it's already tidally locked, so the same face is always facing the sun. It's not even up the correct way. It's not tilted on its side anymore now. It's now just working like a normal planet, just the way the tidally locking stuff works. But yeah, there we go. So yeah, not really too much going on at Uranus anyway. But with the way Uranus works anyway, it already sort of has the sort of effect of being extra cold. So obviously, since the North Pole faces the sun, the North Pole is always going to be that hot spot for about half of the year until the South Pole is in the light. So Uranus is quite a weird one to do it with anyway, and also we'd probably get very similar results to what Uranus normally is like, just due to its weird rotation. So there we go. So we'll go ahead and spawn in another Uranus, and we'll just compare it to that. So yeah, we'll just put another Uranus in here in the same orbit there. Yeah, practically the same there. So this is not going to be altered in any way, but as we can see here, due to Uranus being tilted on its side, we can see that Uranus is always varying, but obviously being tidally locked with the other one, this one is still colder than the tidally locked version, as we can see. And yeah, the hottest point on this one, so if we just go here, the hottest point seems to be minus 207, which is comparable to Neptune. So yeah, Uranus not tidally locked is pretty much the same as what Neptune is tidally locked. So yeah, really not much difference between Uranus and Neptune out of all of these anyway. So yeah, there we go. But anyways, back to our tidally locked one now. And then that's not the tidally locked. The tidally locked one is this one. So yeah, back to this one. We can see here minus 189, minus 190. That's sort of the coldest point. Or the warmest point on Uranus still. So yeah, definitely nothing close to the 0 degree mark. So they're forever cold, no matter if they're tidally locked or not, around our current sun in its current state. So yeah, there we go. But that does it for today's video, guys. So hopefully you all enjoyed. Obviously the results were different, but it had to be done nonetheless. So hopefully you enjoyed it. And yeah, that is everything. So let's see if we can go for 30 likes on today's video, guys, and also subscribe if you're new. Helps on the journey to the next video. Or not next video. Helps on the journey to 12,000 subscribers. Sorry. But yeah, what planet should we do next? I'm thinking Mars. What would a tidally locked Mars be like, I wonder? Let's maybe would you guys like to see that next episode? Let me know down below in the comments there. But yeah, that is everything, guys. So yeah, make sure you all have a great day, and I'll see you in the next video. Goodbye. And that is very insane, but yeah, goodbye. See you in the next video.